If a solution does not contain the maximum amount of solute that the solvent can hold, that's what's known as unsaturated. So how much of a solute will dissolve in a solvent depends on temperature as well as the attractive forces between the two components. But here's a visual of an unsaturated solution. If we add a small amount of salt to some water and that salt dissolves, we have an unsaturated solution. On the other hand, a saturated solution is a solution that has all the solute that can possibly dissolve. And if we add more solute to a saturated solution, that solute will remain undissolved. So here's a visual of a saturated solution where we have undissolved solute in equilibrium with the solution. So when we have a saturated solution, there must always be undissolved solute for this equilibrium to occur. And although the concentration of solute remains the same, there's actually a dynamic process here as these particles, these solute particles, dissolve and recrystallize and dissolve and recrystallize. So we have this equilibrium arrow here between the undissolved solute and the dissolved solute in a saturated solution. Some everyday examples of precipitation or this crystallization out of a saturated solution occurs with gout and kidney stones. In gout, uric acid crystallizes out of solution, and needle-like crystals that don't dissolve form, often in the cartilage and tendons at the joints, in the ankle and feet typically. Here's a picture of gout in a finger, and it is incredibly painful. Kidney stones are another example of a compound that does not dissolve in water. It crystallizes out of solution, and here is a graphic of some kidney stones. These are typically made out of calcium phosphate or calcium oxalate. So gout and kidney stones can be treated through changes in diet and drug therapy, but they are both examples of crystallization of compounds out of solution.